Hello, this is Group 6, and we're going to be presenting the maize disease diagnosis by Group 6 actually. And they are the authors for this research, Mubarak. Then there is Ntanda Chimuli Aloysius, there is Othieno Benedict, and Mukisa Samuel, and the presentation is being made by Mubarak. Now, the table of content, we shall look at the introduction, we shall look at the problem statement, the related works, the research questions, the objectives. We shall look at the methodology we're going to use, the experimental results. We shall look at our conclusion and the future research directions we're going to be having. We shall also look at the references and acknowledgement. Now, in the introduction, we can see that maize has been a great crop. Almost every household, not only in Uganda, but all around the East African region, has been consuming maize, or at least a product made from maize. And I believe everyone has ever consumed a product from maize. Maize is an important food crop, and it is also used as an industrial material in East Africa. And it is most often it's one of the most often traded agricultural items in the region because it's cheap and can easily be accessed by poor people. And as a result, the grain market performance has a considerable influence over the people's welfare. Maize has a considerable influence over everyone, particularly the poor, and is crucial for promoting proper growth. For example, in Kenya, Tanzania, and Uganda, because it's not actually mainly the poor who benefit from it because it's cheap and it's easily accessed. Now, with the growth of maize production, there has been an increase in the number of maize illnesses, the most of which are caused by fungus, bacteria, and viruses. Yes, maize has grown, and we have seen a production in its farming, but still there has been an increase in the maize illnesses, which is caused by fungus, bacteria, and the viruses. And the ability to swiftly and reliably detect these maize illnesses or adopt to the appropriate management measures is critical. If you want to boost the production of this maize product, we should be able to swiftly and reliably detect these illnesses and also adopt the appropriate management measures. Management measures, and it is actually easy to be misdiagnosed, and it is time consuming, and it is also tedious and expensive if at all we are to use the local methods that most local farmers use, like the human visual inspection and also the experience judgment. Most farmers have been using a human visual inspection and experience judgment, but this is not really reliable. Maize disease cannot be identified and treated in real time if we are to use these local methods, and this has actually led to low maize production efficiency. Now, with the advancement of computer technology, we have seen that the use of image recognition technology for disease diagnosis and detection has emerged, and mostly it's being introduced in the agricultural sector in crop disease diagnosis, detection, and other areas. And as a result, this study will also employ this new technology to identify and diagnose these maize illnesses in real time. Now, here we are showing an example of how we have used machine learning in agriculture. The illustration shows you the usage of machine learning in detecting whether a plant is ripe or not. So here, this was an orange fruit, and we were using a mobile phone which had a machine learning model deployed on it. It was detecting whether the fruit was ripe or not. Now, this is one of the key areas where machine learning is being employed in agriculture. Now, the problem under investigation, maize output has declined in East African region in recent years, and this is mainly caused by the farmers' lack of knowledge about the detection of the maize diseases, and it has actually impacted a lot in the maize development. And as a result, there is inadequate preventive strategies, according to this site, we made a citation, shall be showing it later on. And of recent, the Makerere University Air Lab is conducting research and collecting data on diseases affecting maize in the East African region. And this will mainly help assist farmers in easily identifying maize diseases and enabling quick reaction and prevention on the spread of the maize disease in the if affected areas around East Africa. And we also cited one of their articles. We shall be showing it later on. And as a result, the goal of this research is to assist farmers in the early detection. We want to work with the Air Lab, Care Air Lab, to help in designing of these systems that will be able to assist farmers in the early diagnosis and prevention of the maize illnesses. And we shall be focusing on the automated detection of the maize streak virus and the leaf blight, because these two diseases are one of the major diseases that are there in the maize production. Now, the background of this study, we saw that maize is one of the most important cereal crops in the four East African countries, and there was a combined production of more than 13 million tons by 2016. And we saw that some of the countries that had the highest production included Tanzania, which had more than 5.5 million tons, Kenya 2.8 million tons, Uganda 2.6, and the other countries in East African region had like 2.036 million tons. And we also sourced that, and improved maize varieties that were available in the market included open pollinated varieties like long 1, long 3, long 4, and long H. Then there were hybrid varieties like the long 2H, the long 5H, the long 6H, and long 7H up to long 10H, which were also cited. And then there were some common maize production challenges. There were some common maize production challenges, which included the uneven rainfall, there was weak genetic materials, field and storage pests, weeds, diseases, and damaged natural resources like decline in soil fertilities. However, when we did some research or when we did some digging, we were able to find out that maize disease is actually has more impact on the maize production. It's one of the main variables that greatly affects the maize production in East Africa when you compare it to other variables. And when you compare it to other variables, now the significance of our study now by tackling or by looking at the maize illnesses that were revealed in this research, we shall be able to improve on the food security, because as we showed you, maize is one of the most common food crop that is used in East Africa. And if we're able to tackle the key areas like the disease that affect it, we shall be able to improve on our food security. And we shall also be able to improve on the farmers' standards of living, since they will no longer need to spend a lot of money in fighting these diseases. And we'll also actually, when we use this early detection, we shall be able to solve that. Now, the research will also boost competition in the agricultural market, since um, since more farmers will be using our system, there will be less diseases, and that means there will be more maize production, and this will boost competition in the market, meaning that we shall be actually having access to high quality maize products. Now, the development of a new thorough data sets, because we are also considering designing a new data set that will have additional variables compared to, because currently we have a data set but it has less variables. Now I want to create a new data set that will be able to show how other factors affect the emergence of diseases in maize. For example, factors like rain, how do they affect the emergence of this disease? I'll be able to come up with that data set in our research. Additionally, by developing intelligent systems that can increase maize yield, this study will serve as a foundation for modernizing agriculture, because we shall be introducing artificial intelligence in agriculture, and this will actually help improve in our agricultural systems in East Africa. Now, our project scope, although the all populations in East African region, everyone in East African region is affected by a detrimental effect in maize production caused by the maize illnesses. We shall only be looking at Uganda because currently the data set we have was obtained from Uganda. So the images that we shall be using for the classification and the object detection will all be obtained from Uganda. So our project scope will be around Uganda, or the regions in Uganda. Now, there were some research questions. The first one was, what impact does the maize streak virus and the leaf blight disease have on East African farmers? We wanted to know what techniques are currently used by farmers in East Africa to identify and examine and also treat the maize streak and the leaf blight diseases. And we also want to see how can object detection, how can this new system or technology be used to diagnose leaf blight and maize streak viruses. Also want to know what information is available that can be used to demonstrate how other elements like weather or the region impacts the emergence of this maize disease. How these maize diseases are dispersed all around East African region. We also want to know how the leaf blight and the maize streak viruses are spread over East Africa. Now, we also have a research hypothesis. Now, the first one is that what impact do the leaf blight and maize streak virus, late detection, and poor diagnosis have on East African maize production? What would happen if there is late detection and missed or poor diagnosis of this disease? And also, the second one was that we looked at early detection of leaf blight and maize streak. And we, according to this hypothesis, we assume that if at all we're able to carry out early diagnosis and detection, early diagnosis, this will allow for treatment and containment of the illnesses in time, which will actually boost maize production because we shall be able to prevent the spread of these diseases early and also treat it early when it's still in its early stages. Now, there are research objectives. Our main objective is to design an intelligent system capable of detecting and classifying photos of maize leaves that are affected by the maize streak and the leaf blight disease. And we want to also supply farmers. If farmers are able to use their smartphones to detect this disease, we want to supply them with real data on how to treat these diseases, and also we shall provide recommendations on how to properly cultivate the maize. Other objectives include acquiring picture data for the three types of maize like healthy, maize streak, virus, and the leaf blight. We shall also perform the data analysis, cleaning, and preparation. We also want to design and train a machine learning model for the categorization of the data. We shall deploy our model on a mobile application, probably we shall deploy it on a mobile application. We shall establish also a new data set that will be used to show how other factors affect these diseases or the emergence of these diseases. And we shall also look at our schedule. Now, this is our schedule. We shall mainly do our research in 5 tasks. Now, the first task will be carried out from around January 1st to Feb 10, and this will be the data collection phase. Now, the task 2 will commence from Feb 10 to March 24, and this will be an analysis phase. We shall have to analyze our data. Then from March 24th to May 1st, we shall design the model. And from May 1st to August 25th, we shall deploy the model on a mobile application. And also here, we shall be able to design a web application that will be applied, that will be used by our administrators. Now, from August 10 to November 1st, we shall test our system to see how it operates. Now, our methodology will involve gathering data. Now, here we shall use an existing data set that was provided by Hair Lab. And this has 3 classes, the healthy, the maize streak, and the leaf blight. We shall carry out the data analysis and pre-processing. Now the image data will be analyzed and a new class will be added to it. We shall add a new class so that our model does not classify everything as maize or as affected. Now we shall design the model and deploy the model. Now here the group will evaluate an existing model because there are some existing models. We shall evaluate them to determine which of them is more suitable for the classification. And now the suitable model will be modified, trained and tested, and we shall serialize it for deployment onto a mobile application. Now we shall also design a web application, and this will be used by administrators, the National Agricultural Research Organization, to make they'll use because for them they wanted to monitor how the maize disease is spread all over the East African region, and also we shall design a new data set at this stage. Now these are some of the references that we made, and the acknowledgement. We would like to or to convey our sincere gratitude to Dr. Joyce for her insightful advice and helpful recommendations because she really helped us during this research. And also, we would like to express our gratitude to the Air Lab staff for allowing us access their data sets and also in helping us with everything. Okay,